Good day, ladies and gentlemen. Welcome back to our channel, Nambane Academy, Institute for Maths and Science. We had a couple of videos under momentum and impulse, of which I believe they're still available for you to watch if you, in case you missed it. But generally the videos did well and they received quite a lot of reception. Thank you very much for the support, and continue sharing the links and the channels, and subscribe with us, because now today we'll be looking at vertical projectile motion, which will be now topic number 2 of physical science. We are currently focusing on grade 12, but with an intention that eventually we will attend to all grades, but with time, of course. So now with vertical projectile motion, what we do is, by now, if you've watched our first videos, you know that we start majority of our lessons at the center, and we move now with our pillars to explain different concepts. So I will have my center again. Now will be vertical projectile motion. And then the first pillar will be obviously to explain 2 keywords here. Keyword number 1, what is a projectile, and the motion. The word vertical is very clear that it will be a motion either up or down, but anyhow it will be vertical. So I need to explain exactly what is a projectile and the motion thereof that we'll be focusing on. Then it says to me, I can easily explain what is now a projectile. I don't have to think too deep, because what do I know? For a definition, I can easily go to my exam guideline and then the definition will be there. So it is defined as an object which has been given an initial velocity and on which the only force acting on it is the force of gravity or gravitational force. So let's look for the keywords, or highlight the keywords. It is an object. We need to understand that. So an object can be anything, can be a stone, can be a ball, anything that is an object. But that object must be given an initial velocity. So with initial velocity, for us to ensure that it is a projectile, somehow initial velocity should be there. But now it's an object in which the only force that is acting on it is the force now of gravity, or we can further say gravitational force. So this basically says the only force, so one force must be acting on this particular object, and that force must be now what? Gravitational force, or gravity in this regard. So if we have any other forces acting on this particular object, that object will not qualify to become a projectile. Then we further say, how about we explain now the type of motion that this object is going to experience, and that motion, it is called a free fall motion. So we also need to be able to define what is a free fall. So they are saying here It is a motion of an object under the influence of gravitational force only. Gravitational force only. So there's a relationship between a projectile and the motion free fall. So what is the relationship? The relationship or the link here is a projectile is just an object, but a free fall is the type of motion that now this object is experiencing. But for us to be able to talk of a projectile and a free fall, it means now the only force acting on an object in that motion, for it to be a free fall and for it to be a projectile, it should only be experiencing only the gravitational force. So if the only force acting there, I'm going to emphasize this because it's one point that majority of us do miss. If that object is experiencing any other force, it is not a projectile, it is not in a free fall motion. So the emphasis should be the object, for it to be a projectile, then it must only experience gravitational force. Let's emphasize that, let's understand that, because it's going to influence a majority of questions that we are going to experience as we move on with our topic. Then it is important also to have conditions of free fall. Conditions for free fall and projectile. So these conditions, we need now to look for one, we need to be told that we need to ignore air resistance or effects of friction. Let's say air resistance or effects of friction. That is very, very important. So once I am told that the object or ignore effects of friction or ignore air resistance, that is now condition number one. Then condition number two is this one. Now I must ensure that the only force acting on the object is force of gravity. Then I will be able to say it meets the conditions to be in a free fall, it meets the conditions to be a projectile. So one, it must be friction is ignored or air resistance is ignored, and then the other one here, which is key, is this one, that the only force acting on it must be a force of gravity. So it says to me whether my object is going up or down, I should be able to draw now a free body diagram for this particular object. So whether my object is moving up or down, I will be able to say, let me fill it with black. I should be able to say this will only experience one force, which is now the force of gravity. So this is now my free body diagram. I will just fill it up, this one here, and then remember, because it is a free body diagram, it needs to have a label thereof. Then I must be able to say this should be my FW. So the only force acting on it, now I must emphasize that this is for both upward and downward motion. So whether it is going up or down, the free body diagram will remain the same because it is only experiencing FW. But what about acceleration? Because it is now in a free fall, it is now experiencing the only force, or which is now a force of gravity. It says to me, I can have my G now, which is gravitational acceleration, that is equals to 9.8 meters per second squared. What will be the direction of this value of G? It will always be downwards. It will always be downwards. So this is just the basic concepts that we need to know before we can attempt to do any complex calculations or simplest calculations thereof. So it says to me, if we understand these basics, if we understand why do we consider an object as a free fall, why do we consider an object as a projectile, it allows us now to build into what we call equations of motion. So with equations of motion, I have now taken this equations, and these are equations of motions that you find in your formula sheet. But when you look at these equations of motions, these are tools that are going to assist us in terms of calculating whatever that is being calculated. But I need to emphasize a few things before we move further on. All the V's here, they represent now the velocity of an object. Then delta y is basically now the displacement. So if you check velocity, and then A obviously is for acceleration. So if you check all these, including that one, they are now vector quantities. So once we work with vector quantities, it means now we need to work with a choice of direction. So we must choose a direction when we are doing our calculations. So when we work with calculations, it's easy to see that how many variables do I need at minimum. So I will just share a few hints as to how to use the correct and choose the correct equation. So I will say now, under the hints on how to use equations, it's easy. And let me remove this. To use equations, it's easy. Number one, kindly draw a sketch. Draw a sketch diagram for the problem given and label all important parts of the motion. And then at B, obviously choose a direction. Choose a direction. But I usually say we usually take upward as positive. Take upward as positive. So this will assist us in understanding why we choose our upward as positive. unless of course if the examiner is going to tell us which direction to choose. So us choosing upward is positive. Somehow for me it makes things nice and easy to understand, and somehow very, very clear. So at C, it's easy. And now this is for the equations. Write down the given variables. The given variables. So writing down the given variables, you will identify your V final, your V initial, your acceleration, and T. But we only need 3 variables to perform calculations. We only need 3 variables to perform calculations. So let me break it down. We say 2 variables will always be given. 2 variables will be given, and it will be easy to pick it up. And then there's one that is hidden. So this one that is hidden is the one now that wants us to apply physics principles. So we are going to apply physics principles for us to get the final one. So if you are able to get the final one, then we can perform the desired calculations. Because now if you check, if I have my V final, V initial, and my G, then I can be able to calculate for my displacement. Maybe let me remove this here. Let me remove that, and maybe this, such that we can see our equations clearly. So it says to me, I only need 3. So if A is given, T is given, and V initial is given, then the expectation should be I should calculate for V final. But hence I say 2 variables will always be given. Let's go back. We said on this slide here, we said G or A in this case, which is the acceleration, I am at this point, it will always be 9.8 meters per second squared downwards. So it is a constant. So it says to me, when I come this side already, when looking into my equations, I already know that now this one is given and it is 9.8 meters per second. So the only thing that I need is the second variable and the third variable. But it will be easy for me to pick up the 2, hence I already have 1, which is a constant. Then it means I just need to analyze the situation, draw a sketch for my problem, and be able to get now the one that is hidden. So to explain other concepts in detail, we'll have to look at basic questions that we are able to explain few things and different scenarios of what is happening. So let's emphasize on the hints again, so that we are at least able to say when we approach a question, then we are able to answer fully. Under the hints here, it says draw a sketch diagram for the problem given and label all the important parts. So I'm going to try also, when we get into a part where we must do a calculation, I will do that, draw a sketch, label it, and then choose my direction. And then we agree that if we have an upward motion, then we will choose our upward as positive. Then write down the given variables, and we only need 3 variables to perform calculations, of which now 2 variables will be given and then 1 will be hidden. So here is a question. It's one of the basic questions. Then I can read it out and say, let's try to solve this one. And solving this one, we are going to solve it with an idea that we apply now equations of motion. We also apply our understanding of physics principles. And now we emphasize exactly what the question intends on as understanding. Because if you read the question and we move on, we are going to be expected to draw graphs as well. So I'm going to try and explain everything using now this question one. So question one, it says now, it is type 1 problem. So what do I mean when I say it is a type 1 problem? We have an object dropped from a certain height. So under the hints, we are told that black. We are told that we have a building. I'm drawing my sketch here. We have a building, and then we are going now to have the ground. This is the ground. Maybe it's easier if I write it down. So this is the ground, and then this is the height of the building. But we are told that the height of the building is something like 20 meters. But now Paul drops a stone from a high building that is 20 meters above the ground, and then ignore air resistance 100%. So what does this say to me? It says now I am working with a free fall. I am working with a free fall. Therefore, it means I can be able to apply my equations of motion. That is the key words that I need to look for. But there's a lot of things happening here. The first one, they say, calculate the velocity at which the stone hits the ground. So I will do 1.1 here. We have our sketch. We label it now A and B at the bottom. And then the motion of the object, it is now only downward. So what must I do? In this instance, I can choose now my downward as positive. Can choose my downward as positive, because the only motion I have here, it is now a downward motion. So let's check. Calculate the velocity at which the stone will hit the ground. Let's look at that. So for the velocity to hit the ground, they are basically asking me what is V final at the ground. What information do I have? I now know that I need to calculate for V final. I need now to be given some time, which is not given in this instance. Do I have V initial? We'll look into that, but the idea is I want to identify my two easy variables that are given. So my G is given, which is 9.8 meters per second, and then also I have my delta Y here, which is now 20 meters. So these are the two variables that I said will always be given. So this will always be given. So already I can easily see that I need now to have the third one, because I said if I have two, I just need another extra one. But what does this say to me? Let me read the question again. That is where now I need to apply the physics principles. Applying physics principles is, what does this statement drops tells me? So the statement drops tells me that V initial is equals to 0 meters per second. So if you do not apply now these concepts of physics, it automatically says you will not be able to calculate anything, because you will be having two or more unknown variables. So in this case, because of you are told that Paul drops a stone, when it is dropped, then we know that our V initial should be equals to 0. Now this is an incident where we have an object being dropped. So if an object is dropped, V initial is equals to 0. So I can write here now on my variables to say, now this is 0 meters per second. Then when I look at that and then I want V final, I can easily say we're still at 1.1. Going back to my equations, the only applicable equation here should be Vf squared is equals to V initial squared plus 2G delta Y. Then do I have all the information that I need? Yes, I have V final, which is equals to, or V final squared, V initial 0 plus now 2G. Now because it is in the same direction of the motion, it should be positive. So we are going to have 9.8 and then multiply by 20, and then we get our V final as, let me get my calculator, get our V final as something like 19.8 meters per second. 19.8 meters per second. Remember, it is a velocity, it is a vector quantity, so we must also assign direction to it. It will be 19.8 meters downwards. Now that is for 1.1. And then at 1.2, I hope it is clear how I came about choosing the equation that I used, because now choosing the equation is only based on analyzing the information that is given. So we move further on and say, calculate how long it takes the stone to fall. So they want us to calculate the total time there. So at 1.2, the question is basically t. So how can I calculate for my t? I usually prefer not using the previous answer to calculate for the questions that follow. But if the situation allows, then one can do that. But I always try to avoid that. And me avoiding that, I am using the information that is only given in the statement here. Hence, I will always refer and go back and write down my data. So I still have my data y, which is 20 meters per second. Using the physics principles, I knew that because the object was dropped, then it is 0 meters per second, and then my g is always a constant, which is 9.8 meters per second squared. Then I can easily say, if this is the case, then the equation that is applicable is delta y is equals to VIT plus now half of GT squared. And remember, the formulas are given in the formula sheet, so all you need to do is ensure that you refer to your formula sheet, because once you write an incorrect formula, then everything is going to be incorrect, because we'll be substituting into the incorrect formula. Then everything is still downwards and then we said our downwards is positive, so I will have 20 for my delta y. Then I will have 0 for my v initial, and t I don't know, and then I still have half of 9.8 t squared. So everything multiplied by 0 is 0, so this now will fall off, and then I will be able to say here I have something like 4,9 t squared 20, then divide by 4,9 divided by 4,9, then they cancel there, and then I eventually get my final answer as 2,02 seconds. So there's many ways of doing these calculations, but the easiest way is to follow the principles, to use the information that is given in the set of question, or the easiest way is basically follow now the hints that we spoke about. Draw a sketch such that you are able to see the information that is given. Also label now the important parts of the motion, choose the direction, identify the variables, and then remember only only 3 variables are needed to perform a calculation. So 2 will be given and then 1 will be hidden. That is where we apply the physics principles. And then at 1.3 now, they are saying draw a graph of position versus time and use ground as a reference point. So let's draw that graph. Obviously, when we draw our graph, we need to have our axis. We need to have our axis. Let's have another one here. I'll further extend it, and then we are able to say we need to write here now this is position versus time. So this is position versus time in seconds, and this one in meters. But I know that my object started now at 20 meters. And how long did it take the stone to hit the ground? It took the stone to hit the ground something like 2,02 seconds. So what it did, it fell now to the ground. It fell now to the ground. So something that maybe one needs to explain in detail. There's an analogy that I use that I call window. So this analogy, with this analogy of window, what it explains is velocity increases as our object is moving down. So we started with 0 here, which was v initial, that was 0. But now v final, we found now our v final as something like 19.8 meters per second. So when our object is moving towards the ground, or it is moving down, the velocity is increasing. So this will also help us when we look into your multiple choice type of question. So just remember that when velocity of an object increases as the object now moves down. So it's analogies that we use for us to be able to understand and explain a few concepts such that we can be able to answer the questions in an exam. Then at 1.4, let's copy the slide. copy. Then at 1.4, draw a graph of velocity versus time. So drawing velocity versus time, it will be easy to do because all the values are given to us. So let's get there, and then I will just remove this one. Now we are going to draw the velocity versus time. Velocity versus time. Let me basically remove all this. Yeah. Then we are at 1.4. So at 1.4, let's draw now velocity versus time. We have this, and then we have that, and then we need to assign labels to it. So we basically say now this is the velocity, and now this is the time in seconds. So initially we did say that our velocity is 0. So we are going to have now our starting point. How long did it take the ball to hit the ground? We know that it took the ball something like 2.02 seconds. So what was the maximum velocity that it reached? The maximum velocity was 19.8 meters per second. So I can easily draw now my straight line. And then this straight line will say to me my final velocity. My final velocity there is 19.8 meters per second. And then it took now my projectile or my object 2.02 seconds to hit the ground. So this is now relating this information of calculations with the graph. For graphs for what? For now type 1, where we have an object that is just being dropped. So with an object that is dropped, this is what we need to look for, that we are able to draw a graph of position versus time. We are also able to draw a graph of velocity versus time. So velocity versus time, I need to emphasize that now it will always be a straight line. So this must be a straight line all the time. So this is for velocity versus time. And remember, the plus and minus, they only indicate the choice of direction. So in this case, I did say that everything here should be positive. I received 0, and then we calculated, we got 19.8, which is positive. So everything there should be above the x-axis. Then let's go and draw now for acceleration versus time. That is 1.5. So at 1.5, it's acceleration versus time. So with acceleration versus time, it's quite easy to do because our acceleration remains constant throughout. We did say that our acceleration will be now what? 9 meters per second squared, and it will be 9 meters per second squared throughout. So I'm going to write here that we have acceleration, and then we have our time here. But what was our value for acceleration? It was something like 9.8 meters per second. So it was now the same throughout until we got to a point where the object hit the ground at what time? At 2.022 seconds. So this is now explaining the basic graphs of when you have type 1 problem. So when you have type 1 problem, of which we emphasize that the key concept here was when an object is dropped, let's understand that its V initial is equals to 0. Let's understand that we are expected also to do calculations using equations of motion, and we are also expected to draw the graph, because what will happen when we move further on with our lessons is you will be given a graph, and then from the graph you'll be expected now to calculate. But you can only do that effectively if now what? If you expose yourself to different types of questions. So this was the type 1 question. Is the basics. It emphasizes and shows us how to tackle different problems and how to apply now equations of motion and the choice of direction. Then we move to type 2. Say type 2. And then in type 2, an object thrown up from a point and caught at the same point. So we have this object that was thrown vertically up from a certain point, and then it was caught at the same point. So basically what happened is it went up and then it returned now to the starting position. So what do we need to do? Let's have a scenario where we are able to say, this is my object. It is starting here, moving up, and then it eventually let me draw nicely. It is moving up and then eventually comes down to the starting position again. So let's just have our starting position there. So, and let's have symmetry for that. Let's have symmetry for that. The reason why we have symmetry here is basically just to emphasize how are we going to explain now each concept as we try now to apply the science behind all this. Good. So they said we need to draw a sketch. So when we draw a sketch, this is a sketch because we know that it was thrown up from a certain point. So that point I am going to call it A. And then it was caught again at the same point, and then that point I'm going to call it C. So this point here I am going to call it point B. So basically I have two motions. I have motion now from A to B, which now in this case it is an upward motion. I have now what? A motion from B to C, which is now the downward motion. But what can I say about all this? I need to explain now. Obviously, if an object is thrown, its V initial cannot be 0. So I'm going to say at A, what is it that is happening? So I know at A, V initial is somehow greater than 0 meters per second. Definitely. How do I know? I know that because once it is thrown, it means it was given an initial velocity. What else can I say about A? I can say now it's greater than 0, yes, but decreases. But decreases as the object approaches approaches B. So what is the science here? The science is when the object moves towards the maximum height. So at B, we have the maximum height. As it moves now towards the maximum height, its velocity is decreasing. Remember now, what does that mean? It means at B, it must stop before it can change the direction. So when it stops, it says, I can easily say what will happen at B. Then I say now at B, I have my V, which is equals to 0 meters per second. Why is that the case? Is the case because at maximum height, I want now to change the direction. So for me to change the direction, I should quickly stop and then change my direction. So it will not change direction if now the velocity was increasing. No, then the velocity, it means, is decreasing as I move from A to B. Thereafter, I can say now, what else is happening at B? Okay, then the velocity increases as it falls back. It increases 100%. Which analogy can I use to understand that? Is the analogy of window. Now, as the velocity increases when an object is moving down. So I can now understand fully that now the velocity is going to move here with V, that is equals to 0 meters per second, and then V here, let's call it V final, will be greater than 0, obviously. But now, what happens at C? What happens at C? These are the three things that are happening at C. V initial is equals to V final. T1 is equals to T2. So someone will ask, but where is T1 and where is T2? T1, we consider it as this part of the motion here. So this will be our T1, and the second part of the motion will be our T2. So it should be equal. The reason for that, it's now symmetry. It's basically symmetry. That is the reason for that. What about delta y? Delta y now, which is the displacement, it's 0 meters at C. So I can easily say I have now my delta y here for 1, and then I also have my delta y for the second part of the motion. So these are key things that I need to understand when I am working with type 2. So with type 2, object thrown vertically up, reaches the maximum height, and then returns to the starting position. So when it returns to the starting position, it will assist me to be able to say, fine, what other information that is hidden can I be able to get? That hidden information is going to be the information that I use in order to answer questions that follow. So these are the basics, but we need now to apply that in a question or looking at a specific question. So there's a question that I have here, and then this question says here now, an object thrown up from a point and caught at the same point. So that is the type 2 that I spoke about. So this is now type 2. We are building towards more complex problems, but we need to start with the basics. So the first one was, let's draw a sketch, and then from a sketch we label the desired or the most important parts. So I am going to try and read the question and do that. Reading the question, it says now, a ball is thrown vertically upward and returns to the thrower's hand 4 seconds later. So I have an object that was thrown to the thrower's hand and then came back. Now T total here, it's something like 4 seconds. The second hint was, label your sketch for the situation here. Then I am going to label my A, and then for B, and then C once more. I will still use the same principle when I am moving forward to more complex problems. So the basics are going to assist me in getting my answers correct. So if T is 4 seconds later, it basically says now from here to there and from there to here, I know my T should be something like 2 seconds, and then I also have 2 seconds on this side. Then what else do I have? I know basically applying the physics principles, I can easily say now at maximum height, I have V here, which is now 0 meters per second. What else do I have, or which information do I know? I always know that my G now, my G will be equals to 9.8 meters per second. And now I must emphasize that it will always be downwards. So I have analyzed the simplest statement that was given to me. So going to the questions, I can easily apply the information from the diagram and also be able to get now the correct answers. So I am going to try and do all the questions. We'll start with 2.1. At 2.1, they say now calculate the velocity which the ball left the thrower's hand. So what is the question? The question is basically asking us for V initial at A. So I know now where is the position that I need to start calculating for. So it's either I calculate for the whole motion, or I can now break it into sub-motions. Me breaking it into sub-motion, I can easily say now for the motion A to B. So I will be looking only at information given to me at now what? A to B. And then now, because I have my sketch, I have the motion that I'm going to look for, then I need a choice of direction. We emphasize that once we have an upward motion, we are going to choose our positive, our upward now as positive. So up as positive. So everything that is going up will be positive and everything that is going down will be negative. So I'm going to write down my variables. My variables are V initial, VF, G, delta Y, and T. Then I read the question once more, and from the analysis or the sketch that I plotted, it's easy to say the question is asking me for V initial. What is my V final at the motion for A and B? My V final now, it's 0 meters per second. What is my G? My G is 9.8 meters per second squared. Do I have delta Y? Unfortunately, I don't have. Do I have T? Yes, I have T. T was given as 2 seconds. So you can easily see that this T2 or T, which is equals to 2 seconds, was easily given from us applying symmetry. But this one now of V final being equals to 0 is the science principle that we need to apply. not necessarily a principle, but the concepts that allows us to answer questions the right way. So it's easy now, all the information is there. One can easily say VF is equals to VI plus GT, which will give us 0. And then V initial is what we are looking for. And then plus minus 9.8 multiplied by 2. Remember, the minus is because now G is in downwards direction, and then we chose upward as positive. Then we calculate our V initial as something like 19.6 meters per second. It's velocity, so we need to emphasize that it was moving upwards. So the fact that we are able to choose direction, the fact that we get answers, it assists us in terms of saying this is the correct answer because it supports positive in the direction of the motion. And then at 2.2, sorry, the height reached by the ball. So the question wants us to calculate the displacement, and now this is the question for that. So the displacement here will be, what variables do I have? Do I have V initial? Yes, I have my V initial. It's 19.6 meters per second. Do I have my G? It's always given, which is 9.8 meters per second squared. Do I have a V final for the motion? V final, I know V final is 0. And I must emphasize now, this is for A to B. Then the equation that I can use when I check the variables given is VF squared is equals to V initial squared plus 2G delta Y. I use G because of acceleration or gravitational accelerations. Then this is 0 squared. This is now 19.6 squared plus 2 minus now 9.8 delta Y. Then you do your calculations, you'll find that delta Y is something like 19.8 meters. And then they did not ask us to calculate the displacement but height. Then we need to conclude that the height now is equals to 19.8 meters per second. Sorry, 19.8 meters. 19.8 meters. 19.8 meters. So this is our final answer. Then 2.3, the total displacement covered by the ball. Now, the displacement here, or the answer is 0, but I'm going to try and explain it in this way. Total displacement is just a displacement for AB plus now the displacement for BC. But because of symmetry, we know that this one, it will be 19.8 plus minus 19.8. Why the minus here? Because BC is for our downward motion. So our final answer here will be 0 meters. So the displacement at covered by the ball, it's 0. But now there's a difference. We need to understand that this distance now is what? A vector quantity. So distance, sorry, it's not a vector quantity, a scalar quantity. So it has nothing to do with the direction. So we can easily add the two and say we are going to have 19.8 plus now 19.8, which will give us something like 39.22 meters. Then using symmetry again at 2.5. So, okay, maybe I should emphasize again at 2.3. 2.3, displacement is a vector quantity. That is the reason why AB will be positive, BC will be negative, because now of the choice of direction. Then we get 0 for our displacement. But the distance is a scalar quantity. So it being a scalar quantity, we only add now our two distances that we have there. We do not consider the direction thereof. So at 2.5, it's easy to say, calculate now the velocity at which the ball returned to the thrower's hand. Symmetry again, no need for calculation. It should be 19.6 meters per second, and now this is downwards. So because we are assigning the direction, we easily know that this should have been negative. So I am going now to add another page, or maybe let me just duplicate this one. Let's duplicate this one so that we can do the final question. And the final question is, draw the velocity versus time. So drawing velocity versus time, it will assist us in terms of understanding exactly how we draw these graphs. So velocity versus time, the easiest way of doing it, let's have our axis. Let's have our axis. So let's remove, delete a few, or maybe let's delete this. Then we have our axis. Have our axis. Then we know this is velocity. Sorry, choose my pen. This is velocity, and now this is time. But what was the initial velocity? We know that initial velocity was 19.8, and then at some stage we had time, maximum time, which was 2 seconds, and then we had our motion being completed at 4 seconds. But we also knew that we had now the final velocity, which was 19.8 as well. Then we are just going to plot our graph, 19.8. So I'm going to take my straight line graph and then just have something like this. Then let me just correct this and that, and then I have my 2 seconds here. So this will be my 2 seconds, and this here will be my 19.8. So this will be my velocity versus time. This will be my velocity versus time. So you can easily see that this side here represents the upward motion, so I can assign A to B, and now from here is B to C. So the point of me ensuring that I assign specific values or specific labels, it helps me even to understand my graphs better. So for me to you, thank you very much. This is the first part of projectile motion. We'll obviously be recording more, part 2, part 3, and I believe we'll even go to part 4 of this particular topic. So kindly subscribe on our channel, like us on Facebook, tell a friend, just to ensure that each and everyone that needs support or help in physical science, we are there to assist and support. So from me to you, thank you very much and have a lovely day.